Hey, looks like we're live. I'm just going to take a step back because then I can actually see you guys. There's so much bright light coming at me. Thank you very much for showing up under these circumstances. I'm really happy to see people here. I was a bit afraid. And let me get something off my chest right away. I might have lured you here under false pretenses. So who can claim best practices in this world? I think maybe if you have a surname Fowler, you can get away with that. So what I hopefully will give you here is good ideas, right? They're not going to be dogmatic. I'm not going to go and tell you this is what you always must do. This is good ideas for inspiration. I hope they're good ideas. And I hope you will enjoy them. And if you don't, give me feedback, right? Or if you have some input, I want to learn, like everybody here, right? So with expectations sufficiently lowered, I hope we can get going, and maybe I can get you from a red card over to a green card by the end of this talk. So who am I? My name is Egil, and I'm from Denmark. I live in Iceland, and now we're here in Norway, so we're just missing Sweden in there somehow, and then we have the whole Scandinavia almost. You can find me on Twitter at Egil Hansen, and if you are watching this from the future or just from your hotel room right now, feel free to tweet at me. I love to answer questions and help out, so that's okay. I am a developer at this great company. It's Delegate, Danish IT consultancy. We specialize in the Microsoft ecosystem, so everything from low-code solutions all the way to big custom solutions in Asia and building on the latest .NET tech. We have a bunch of these stickers on our website. I'm not sure what they exactly mean, but if some of this sounds interesting to you, we're always looking, like everybody else, I guess, for new talent, for great talent. So if any of this sounds interesting to you, feel free to reach out to me and let's talk. Right. Anyway, I'm also Microsoft MVP, but more importantly for this talk, I am the creator of bUnit, the testing library we will cover here. If you for some reason or another, would like to see more of me, you can do so. I try to be very regularly live streaming on Twitch, just coding on bUnit or other open source things. And feel free to come and hang out and ask your questions or just make fun of me. Everything is valid there. Quick disclaimer: I don't know how many of you attended Chris Saints' workshop earlier this week or just have a general knowledge of Blazor and testing in general, but I won't cover those concepts here. So it's not a beginner talk of covering Blazor or just testing. So if you're completely new to that, that's going to be some words today that you might not understand. That's okay. You can ask afterwards if you like. Okay, so let's start with the first question. What is bUnit and why do I need it? And well, the first question would be, what is bUnit? So bUnit is a library obviously for testing Blazor components. But the reason why I sort of underline library is because it's not a testing framework like you would normally use for writing your test, like you would use XUnit or NUnit or MS Test. Those are test frameworks. bUnit is a library that you add on top of that, similarly to what you do when you add something like a fluent assertions library or a mocking library. So bUnit is something that we add on top of our testing frameworks in a similar way. It's a library that enables us to test Blazor components, obviously. That also means that bUnit tests will sort of look and behave exactly the same as your regular unit test, right? So because it's just something we add on top of our existing testing library. That also means that we can reuse all the good patterns and practices we have around structuring our tests. You can basically continue writing your tests like you would normally in bUnit. One thing I do want to highlight that might surprise people that have maybe done some Selenium testing or similar front-end testing previously in the .NET ecosystem, where you have a browser involved, where maybe Selenium is sort of, it will spin up a browser in the background and it will hook into that and instrument that and look at what the markup is being generated, and you can sort of interact with your application under test through Selenium. But bUnit doesn't do any of that. And that also means it doesn't run any of your JavaScript. So it runs entirely under the, for example, XUnit runner, and everything in there there's no JavaScript engine in that. So if you have a component or an application, Blazor application that uses some JavaScript, well, your JavaScript won't be tested with bUnit while you are testing your components. what we do have in bUnit is a way for you to set up those expectations, very much like a mocking library, where you can say, well, I expect my component to make this call to JavaScript, to the IJS runtime, and that way you can sort of test the expected interaction. And I think most Blazor applications actually don't have too complex JavaScript. Most of the JavaScript we will have in our applications is not application logic, it's more like enabling us to call maybe some browser APIs. So for the most part, that's not going to be a problem. But if you have complex interactions, maybe you're building a complex component library where you do have a need to sort of do that end-to-end testing, maybe look at it's not Storytel, but the new thing that Microsoft is also coming out with for end-to-end website testing. That's going to be the option you want to go with. And but the advantage of bUnit not running any browser under the hood and not doing any of the usual end-to-end browser front-end testing is that the test runs just like regular unit test. They run fast, like we're talking milliseconds here on a regular PC. So you get the speed and benefit, and we also have fairly deep hooks into the Blazor render, which means that we can make the tests quite a bit more stable and predictable. But let's see just what I mean by that. So here we have a regular XUnit CSproj file from the .NET 6 era, and we need to make a few modifications to that to enable bUnit. So the first thing we want to do is we want to change the SDK to be the Microsoft.NET SDK Razor type, because we need to write Razor files in our test library. So that's all we need to do. And obviously we need to add bUnit as well as a package reference, and that's all you need to do. The next question we might quickly want to cover is, why do we actually need bUnit? So a Blazor component itself is just, when you look at the generated markup from a Blazor component, or just create one manually just in a C# class, it's actually just a C# class, right? So before I built bUnit, I wanted to test my Blazor components, and I was like, let me just new that thing up and try to test it from just an XUnit test. But you quite quickly realize when you attempt that well, you need a few things. Components have lifecycle methods, and sort of to be truthful to the environment that a component would be used in production, you have to emulate that lifecycle and call the methods at the right time under the right circumstances, right? So we have to do that. That's something bUnit will help you with. Another thing bUnit helps you with is parsing parameters and injecting services into your components at the right time in the right way that the Blazor runtime does it as well. Another thing bUnit does is allow you to call event handlers. So event handlers can sometimes just be public methods on your components. Sometimes they are actually just inline lambdas on the markup itself. That's going to make them a bit harder to call. Most of the time, I would assume they're going to be private methods that you have in your components. So again, it's kind of hard to call them in a test. So bUnit will help you with that as well. And when you think about it, the architecture of Blazor works such that Blazor component doesn't actually know how to render markup output. It sort of contains this description of what we want to produce through the Razor language, which is a template language, and then we need something else to turn that template into markup that we can show on screen to the users. And that is also something that is also why we need actually a real Blazor runtime underneath the hood to do that for us. And luckily, that is basically what bUnit is. bUnit builds on the existing Blazor runtime and the Blazor renderer, but just instead of sending that output to a browser, well, we capture that so that you can inspect and work with that output from the component. We capture the instance of the component so you can inspect that as well if you need to. So that is why bUnit is necessary. So what does the hello world of bUnit look like? So we've all seen this component. Is there any Blazor developers in here that hasn't seen this component before? So this is the counter component, and in case you've forgotten what it looks like, you have that button and you click it and the counter increments. So what is the test for this? How does this test look? Well, to begin with, obviously we are going to go into a Razor file. So this is a counter test.razor file, and the first thing we need to do is obviously have a XUnit. I'm using XUnit in this case, so we have an XUnit test here. And the first thing we need to do in that test is to new up a test context. So the test context, you're going to see that all through this talk. It's a bUnit thing. That's the thing that allows you to do things with a Razor component. So when we have one of those, well, we can call its render method, and we can pass in the counter component, tell it to render the counter component. The result of that is an iRendered fragment. and it's abbreviated. The variable is abbreviated CUT for component under test. So if you know regular testing nomenclature, that would be system under test normally, but I sort of changed that to be component under test. That makes sense to me. So now we have the component. Now we need to click that button. And how do we do that? Well, we can go ahead and actually use a CSS selector through the find method to go and walk into the document object model. So we actually have a full document object model through the AngleSharp library that we're using under the hood to go in and find elements, document objects in the DOM tree that was produced by the counter component. And we're going to look for the button component, and then we will call the click method. The click method is an event trigger method that will go ahead and trigger that onClick event handler method that was on the button component in the class, in the component. And once we've done that, well, now we go ahead and find the paragraph component, the P tag, in our component, and then we use this method here called markup matches. It's a custom assertion method in bUnit that will allow us to pass in some markup that we now expect the paragraph component to contain. In this case, we want the one to be incremented from 0 to 1. So now we should set current count as 1. And so if you haven't seen a bUnit test before, you might sort of wonder, what are these things I've highlighted in red here? And it's inline render, and it's a mouthful. Inline render fragment. I think it's actually have a more official name, but I call it inline render fragments. So this is sort of amazing that you can, in Blazor, you can actually have a razor file where you start out in the razor context, then you add the code block, and then you go into C# context, but then from the code block, from C# context, you can actually enter back into razor context and write markup just like you would with code. And you have syntax highlighting, you have IntelliSense on the HTML, so that makes it much easier to sort of describe the component you want to test, pass parameters to it, and also provide markup that you want to verify against. And you can obviously run and write your test in C#, then you don't get access to this notation, then you have to use sort of a builder pattern I have around that, for example, to pass parameters, and you have to use strings when you want to verify markup like this, and that can be a little bit tedious if you want to escape, so attributes, for example. That's things like you have to escape in that case. So now that we have a test, how do you run it? So running a bUnit test is just like running any other .NET test, basically. If you can run it from .NET test, you can run bUnit test. I've added an extra argument here to get us a little bit of better logging output. So when we run the test, we get that one. And you can see the test run, and everything is happy, and everything is green. That's good. So now that you know how to build bUnit tests, the next question you might want to answer or ask is, what do I actually verify? Do I look at the markup, or do I test component functionality, or something completely different? So let's cover that. So let's start by what I would call functionality testing or component logic testing. I don't know how many of you have seen the Blazing Pizza workshop before. A few of you. Okay, if you haven't, there are some URLs at the bottom of the slide here. You can go and check that out. If you're fairly new to Blazor, it's a great workshop to work through. You would see there's 2 URLs up there. One of them is to not a new version of the workshop, but it has a version of the workshop where I have added tests for all the components. And there's also a whole video series I did online on Twitch where I go through the full workshop. It's like a 24 hours something total, so you might want to fast forward through some of the bits. But anyway, in this case, we just have a dialog box. So a user has selected a pizza they want to buy, the buffalo chicken, and now they have the option of adding extra toppings. So that is sort of the component on the test we want to test. So how would we test the functionality of that component? So first, obviously, we need our tests. So selecting toppings from dropdown adds it to pizza. So what do we want to add here? Well, first we need a test context, and then we need a new pizza. And now we can go ahead and render our component and the configure pizza dialog, and we pass in a pizza. So it might look like I'm actually passing in the string pizza here, but it actually works just like it works in real Razor markup. It's actually that pizza variable there is pointing all the way up to the pizza we have instantiated just on the line above. So the next thing we need to do is we need to go into, again, using the find method and passing in a CSS selector. That will allow us to find the select drop-down list, and then we just call the change method on that. That is a callback that will trigger the onChange event handler that is bound to the list to the drop-down list, and that will change it to a topping value. And now our assertion will be, well, now we assert that the pizza's toppings list is no longer empty. So the key thing here about the functionality testing is that we have very little tie-in to the markup that is actually rendered by the component. The only thing we really focus on is we are a little bit tied to the markup in a way that we have a selecting, so a select there where we go and pick out something from the DOM. But all the other markup that's been generated, all the drop down, everything inside of that, we don't really care about that. So that means that our component, this test for the component is likely going to keep working and keep being green, even if we go and change around a few things in the markup, add another attribute or something to the drop-down list, or change the styling, for example. So this is sort of what you get with functionality testing. You poke at the thing and you watch it react to what you do. Another thing we can do, if it's important, you can go and verify markup. And you might want to do that if you, for example, have a designer, or you are the designer in the company that told you that this CSS and this markup goes together, and if they know if the markup isn't exactly like this, well, then we have a problem, because then things don't work as expected out in the browser. So sometimes it actually makes sense to go ahead and verify markup that is produced. And historically, that has been a bit hard. And because if you take a string of HTML and compare it to another string of HTML, you can do a lot of things to that original string of HTML that will still make it semantically the same, but will not really actually be, if the string equals won't work. It will like break the test, even though the markup is actually still fine. So the point here I want to make is, if you want to verify markup, do it semantically. And bUnit has a semantic comparer that can help us do that. So semantic comparison means that two HTML bits are the same if they actually look the same to the user in the browser. The opposite is obviously what I told you before, is that, well, if you use string comparison, well, then you're going to have a harder time making that test stay green every time you do a little bit of refactoring, move around white space. Let's look at an example, so sort of to get the point across. So suppose we have this buttons dialogs buttons razor component with this simple markup in it, and we have this test that verifies that the markup is correct. And the key here is the markup matches method that's built into bUnit. That is the semantic comparer that is built into bUnit. So if I go ahead and change my dialog button, just do a Control-KD maybe in Visual Studio and reformat it, well, this test will still pass, because these two, this markup we had before on the dialog button and the one we have now, they will look the same to the user in the on screen. We can also go ahead and change the order of attributes in that component, and the test will still pass because they work the same for the user in the browser. We can even go ahead and change the order of the classes in the class attribute, and the test will still pass. It won't care. Another thing we could do is, well, maybe we have an ID attribute in this case where some of it is generated, or it's an GUID or something. Well, that's going to be quite hard to test because it will change every time you render the component, right? It's sort of like you want a unique ID, for example. Well, we have in bUnit's semantic comparer, we have what I call comparison modifiers. In this case, we have the regex modifier that's highlighted on screen now, where you can pass in a regex, and instead of using just straight up comparison, it will use a regex comparison. So that allows you to sort of again handle that scenario where you don't want the test to break. There's many more. Another one that is quite common to use is this more general diff ignore modifier, that basically says, I know there's supposed to be an element here, but just ignore it. We don't care about that. So now we know sort of different approaches to what we can test and how to do that. But let's change gears a bit and talk about what is a testable component and how do we write maintainable tests. And I don't know how many of you in here like test-driven development. I'm personally, that's sort of something that suits the way I work, and it makes me feel comfortable. It makes me feel like I can, better get to a state where things are done. But that's not really the point of this. So you can do test first or test after, either way. But the point of us writing tests in the first place is to be able to maintain our code in the future, obviously also to verify that the thing we are building right now is working as intended. And so if writing tests doesn't necessarily make sense if you're just doing a quick prototype of something, unless of course you're prototyping with bUnit and trying things out with bUnit. So, but I want to talk a bit about what it means for me to create testable, maintainable components, because that's sort of where we start. And again, I want to iterate, this is just my approach, and it's definitely not necessarily the right approach for everybody and for all scenarios. So take this as good ideas and not dogma, right? So I think a component should do one thing well. And what does one thing mean? Well, it's sort of perhaps hard to define, but there could be a few code smells or component smells, I guess, that we could look for to sort of identify when a component doesn't do that one thing. So one thing I would like to look for in my components is if there's a mix of abstraction levels. And even the term itself, abstraction levels, is abstract. So I'll show an example in a little bit so we can sort of see what I mean by that. Another thing would be the level of cohesion. And generally, if the component has low cohesion, again an abstract term, I'll show an example, then that might be an indication that the component is more complex than it needs to be. And one thing I see, and I see that in a lot of demos, maybe I can't even remember if they still do that in the hello world when you sort of find a new project Blazor, they inject HTTP client directly in a component. That's not super ideal, especially not for testing, but it also sort of limits you that you basically have your HTTP code directly in your component. You might want to move that into a service. So in general, don't have infrastructure in your components. Put that outside, similar to what we do when we're building business logic. This is component logic. Keep service, keep infrastructure, keep databases and HTTP clients and what have you out of your components and work with abstractions instead. So to sort of have something to look at, let's create a dynamic data table component. So this is the grid test that we've all seen a few times. So our dynamic data table component will work like this. Here at the bottom of the screen, we have a data table component. We pass in some movies to it. And the movies is defined above right now, but that could come from anywhere. And when the data table component renders, it figures out, based on the movie type, what headers to add. And it also figures out, how to render each of the columns, each of the rows in the table based on the data we pass into it. So this is sort of a very dynamic, I'll figure it out for you kind of a component. So how do we build something like this? Well, the first thing we need some system.reflection, because this is clearly going to use reflection to figure all that stuff out. We also need it to be a generic component, so that's why we have a type parameter on top. And then we need a parameter where we can pass our items into. Then we need some reflection magic. This is going to go and find the items property info, and it will only find the public properties of our item that is public and that is instance and that we can actually read. And then we need a helper method to be able to get the names of the columns. So that is this method here. It will go and get the names of each of the properties that we can read and that are instance a part of the item. Finally, we need a little bit helper method that can go ahead and fetch out the data for each row. That looks like this. And if we scroll down a little bit, we will see that obviously we need a table. And we need the table head. It looks like this. We have a for each over the column name, and we print out in a table row, we print out the table header cells and with name of that. And finally, in our T body, we have a for each again over the items, and then in a table row, we for each over each of the cells in that table row and print that out. So this is the total of that component that will do that thing. So quite simple, but still. Is there things that we can do to make this more testable and maintainable in the future? Is there any code smells that you are thinking that even this simple component, I think maybe it's 30 lines. Is there something that actually could make this more easy to work with in the future? Well, if we go back to the examples we had before, sort of my recommendations. The first thing, I've sort of skipped away a few things here, but the first thing is the mix of abstraction levels. So what do I actually mean by abstraction levels? So an abstraction level is, like in this case, we have a component that works. This part of the component sort of deals with the items, the plural, that's sort of a higher level of abstraction. We're working with multiple items, whereas this bit of the code works on the individual item. And that is sort of a mix of abstraction level. That's two things that you might sort of indicate that maybe there's something here I can pull into subcomponents. And another thing we talked about was the cohesion. So we want to eliminate low cohesion. So low cohesion, what does that mean? Well, let me illustrate that by saying, well, these two bits here that are red now, they clearly are dependent on each other. There's a coupling between them because the markup is using the method up there. But the blue bits here, they don't have any relation to the red bits. They could exist somewhere else, and the red bits wouldn't care. So that is sort of an example of low cohesion. And the concept of low cohesion is something that also applies to classes and just regular plain old C# objects, in that you can have an object that grows too large, and one of the indicators of that is that it have parts of the class that deals with things that it only uses a subset of the fields, for example, only uses a subset of the properties there. So the same thing here, that also is an indicator that we have things that don't necessarily need to be in the same component. And we can simplify things. So let's do some refactoring. The first thing we would like to do is probably to take that thing that they have in common, that item property, info property. I realize that name is going to be a mouthful. And just refactor that into a helper class. So we have a data helper type now that has that functionality in it, so that we can reuse that across components. And let me just show you what that looks like. So you can see we just move that property into a class, and now it's a method, and we can call it, and we get that information out. So the next thing we would always want to do is get rid of that header stuff. So let's pull that out and add in instead a data table header component. And the only thing that data table header component needs is actually the type, the T item type, because that's all it needs to actually render out the header columns. So, and here we have a data table header component, and you can see this is a nice, concise component that's easy to understand what it does. And let's go forward with the next thing. So the next thing, and I'm probably sure you guessed that by now, is that we have the row bits we move out, and we end up with a data table row where for each of the data table rows, we pass in an item. So this data table row component is now responsible for rendering a single row out. And as you can see, it's also very simple. And now this is the final refactor data table component. Again, focus, simple. There is sort of one abstraction level here. We're only working on items, the items plural level, and we sort of delegate the responsibility of the individual item of the header down to child components of the data table component. And I guess one argument you would say, well, this was so simple. Why do you need to take that step? Well, this is also very rudimentary. It's not going to take many weeks before your manager comes and says, can we get some sorting in here? Then you start adding logic where you can click on the header, for example, that should do something, and then it should start sorting somewhere else, and maybe you want some editing in the cells, and all of a sudden you have a component that went from a nice 30 lines to very big. Instead, now you can move that logic out into the different child components and still have fairly clean, cohesive code. So it might seem overkill, but I actually think there's some meaning to the madness in this case. So now that we have something we want to test, so how do we create maintainable tests? It turns out when I was doing this sort of building the slides for this talk, many of the recommendations I'm going to give here now in terms of building maintainable tests are actually going to be generalized to unit testing in general and not be specific to Blazor components. There's going to be some, obviously, but in general, I like, even in my just regular tests, to avoid duplicated code within tests. So I don't mind duplication across tests necessarily, test classes, but I would like to avoid duplicated code within a test class. So all tests in a test class should sort of be very, they should have the same sort of tight target. They should have the same system under test or same component under test in this case. But you might have components that exist or other tests that might have some similar setup logic, for example, but then you might end up with, if you have too much shared code between test classes, then you might end up in a situation where you can't change the test logic in one class without actually breaking another test. So I don't follow the no duplicated code religiously, but at least within a test class, it's always a good idea, I think. So how can you get around that? Well, use sort of move common arrange code or setup code into the constructor of its XUnit or into the appropriate setup methods in your testing library. So you sort of have that duplicated code moved somewhere else. I also like to use creational patterns to create input for tests, and I also enjoy using tools like AutoFixture or POCOs to generate test data that is not really specific to the test, but just data that needs to be there. And if I'm building using creational patterns to create test data that is actually test specific, I like to try to use the business domains wording, because that's again going to make my test easier to read and understand. If I have sort of high level language that explains with this input something is going to happen. This is obviously a Blazor specific point, but only verify markup that belongs to a component under test. So if you have a component that has multiple child components, use, for example, the diff ignore to ignore subparts of the markup that you are from the component under test that belongs to the child components, because you don't want your component under test to break just because a child component changes the way it renders output. You don't want that. You don't want test breaking when there's no reason to. And finally, I've heard people talk about this before, but I like to say stick to one logical assertion per test. You can have multiple assertion statements in your test, but a test should primarily have one logical assertion. So that means one sort of business rule. And one thing I like to do, and I'm a big fan of fluent assertions, is to actually create custom assertion methods if I have multiple assertion statements, so that I'm getting down to one assertion line. Again, just to make my test readable, more maintainable, more easy to understand when I look at my code again in half a year, or God forbid somebody else does. So let's do some testing. Let's look at testing the data table component. And the first refactoring we can do from the first examples is to, well, let's have our test class or test component, in this case, inherit from bUnit's test context. Then we don't have to new that up in every single test. So that's a little bit of niceness there that allows us to just call the test context methods directly. So now we can go ahead and write the first test, and the test is going to be the most simple thing we can come up with. Data table renders basic table with head and body. So this is our verification of the markup produced by the data table that it owns. And the only thing we do is we call the render method. We pass in the data table, and we don't pass any items because that would be a more complex scenario. We just pass in an object as the generic type so that we get the most basic test we can do. And now we just use the markup matches to verify that the markup is indeed right. And here we are using the diff ignore children because we know there should be a t head there, but we don't care about what the data table header component, the child component, is generating. So we are just telling it to ignore the child content of the table head. The next test we might want to write would be to sort of test that composition, that interaction between a data table and the data table header component. So even though we are not going to test the markup output from the data table header component in a data table testing class, we want to test that we are passing the right stuff down to the data table header component. So it's like what you do with testing, that's sort of the interaction testing between them. So how does that look? Well, now that we've rendered the data table component, what we can do also with bUnit is we can go and inspect not the DOM tree, the produced markup, but we can go and inspect the component tree. And we do that with the find component method. And we tell it to go ahead and find a child component of type data table header with a generic type of object. And if it doesn't return anything, it will throw an exception. So at this point, we could actually stop and say, well, as we certainly did add the right child component into the component tree. But if we want to go one step deeper, we can go and say, well, let me find the t head in our component on the test, the data table, find the child nodes, and say those child nodes should match whatever the data table header component produced. And this I'm sort of have this as an example. I probably wouldn't do this in practice, but what we are actually doing here is even though the data table header component changes its output, this test would still pass because we're basically just saying whatever you have, it should be in that t head, and that's it. Okay, so I'm going to skip showing you a test of data table header because it's not going to be very interesting. Let's jump a little bit further down and do a test of how the data table uses the data table row. So again, an interaction test, a composition test. So first we need a couple of movies to pass into our data table to have something, otherwise we won't get anything rendered out by the data table header. We won't get any iterating over and adding data tables to a component. So we render our data table component again, and here now we can use the find components. Might see that there's an S there, so it's a plural thing. And we find all the data table row components that was added to the component tree. And now, well, there's a little bit of magic we can do. So the result we get out of that contains an instance that references the actual data table row component, and then we can go to the item of that data table row, and we can see this is the item that was passed in. So now I have an enumerable of movies, and those are the movies that were added to the rows in our data table. And here I'm using fluent assertion. It has a fairly magical and fantastic method called bEquivalent_to. So now I can say all the movies in my rows, they should be equivalent to the original movies. And this will verify that the individual movies are there's the same amount and they are in the same order. So this is sort of a test where we're testing the integration between the data table and the data table row component. So let's look at a test of the data table row component. The first test is just the empty test again, to make sure that it works in the basic test. This is not very interesting, but you might want to have those like the start. When you do test-driven development, just kind of start with the most basic test, and then you're writing something like this. The next test is a bit more interesting. Here we pass in, because the data table row is only responsible for one movie, here we pass in a single movie, and now we can do markup matches again and verify that it does the right thing with that movie. We don't have any functionality at this point in our data table row. We just render out output. But as you can see here, this is actually kind of great feature you have. You can even use that. So as you can see, we're building up a render fragment that we pass to markup matches, and that actually points back to the movie we originally movie variable a few lines above. So this again will verify that data table row, if passed a movie or passed any object, will do the right thing, or at least with a movie, I guess. So to summarize, what have we done with this testing? Well, we have verified the component markup in isolation of the different components. Well, we skipped the data table header, but I think you get the point. And that allows us to evolve the data table row and the data table header and the data table component individually without having their own test breaking. And that's important. You don't want test breaking in general in your unit testing because something else changed, right? Another thing we also did was we verified I call it component composition, might be a fancy word, the way the components work together. And that is something that we do want to verify, especially from a data table to its child components, because that's part of the contract. They have like a public contract, and we want to make sure that we're passing in the right things and maybe getting the right callbacks. So let's look at another approach to sort of work around the issue of the dependencies that are between components. So isolating the component under test. So in this very basic example, I have a foo component, that's my component under test, and it has a child component. Well, you can ask the question, should changing bar break foo's test? Sometimes maybe. It's going to be it depends kind of an answer, but if we answer no to that question, then we might want to not have bar be part of our test. But how can we do that? Well, let's get back to that. Another question we might ask is bar a third-party component? Maybe, and I know it's quite common that we will take a third-party component with some great components in there and use them in our Blazor application because that makes us go faster. And we don't have to do all that hard logic, perhaps. But we don't want to test the third-party components in our test, right? Because that's not our code, it's not our responsibility, and that will also tightly couple our tests to third-party components in a way we probably don't want to. So not only when we upgrade to the latest version of that third-party component, we have test breaking, but we might also have other different issues there. So sometimes you want to actually pull away. The thing we don't, unfortunately, we can't just remove things from the component tree because that's sort of something you statically coded into your Razor files, but we can substitute components, and that's sort of down to how Blazor works. So what do I mean by substitution? So let's look at an example. So if foo doesn't have a bar, that's our test, and we render foo, we want to have an assertion that looks a bit like this. We can use the has component as a bUnit method, where we can ask, do the component on test have this child component? And the answer to, do you have a bar component? That should be false. But do you have a bar substitute? Well, that should be true. And how do we get around that? So there's it's been around since 1.2 of bUnit, a concept of component factories. A component factory is the way that bUnit allows us to control what instance of a component actually is. So Blazor will ask bUnit's component factories, can you create please create me this instance? And then bUnit will ask all the component factories, can you create this? And the first component factory that says yes gets a chance to return an instance of what was asked for. But Blazor actually, for the most part, doesn't care that the instance is the right type. So that is where the component factories type come in. So let me just show you what this particular bar substitute component factory look like. So it's just a thing that implements iComponent factory. It has the two methods. It has, can you create this type? And in this case, we say yes if the type is a type of bar. And then the create method gets called, and we just return a bar substitute because that's how we roll. And the bar substitute is just a very boring Blazor component. That's the only right thing it is. So how can we use this? Well, this is the test we had before, where we had to use that diff ignore children diff modifier. Well, what if we can do this instead? So to save you from writing a whole bunch of iComponent factories, there are obviously some of them built into bUnit to make it a bit easier to work with. This is sort of the very basic one that is available through this add method that has two generic parameters. The first generic parameter is the type of the component you want to remove from the DOM tree or substitute out, and the second generic parameter is the parameter is the type of the component you want to substitute with. So, and again, the header substitute just looks like this. And now we have a more clean markup matches call where we just specify the markup that is relevant for the component under test. So there are a few rules for creating substitute components. And the first rule is that, well, it has to be a component. Maybe not surprising, but all Blazor components have to inherit from iComponent. That happens by default if you inherit, if you build on component base. But at a very minimum, a component has to inherit from iComponent. A substitute also has to implement or have the same parameters as the component is substituting. Or, and this is a super neat trick that was just perfect for this use case, it can also have just the capture unmatched values type of parameter. So imagine we have a component with a bunch of parameters, and if we return a different component to Blazor, Blazor will then at that point try to bind all the parameters to the properties it is expecting to find there. But if there aren't none, it will look for the captured unmatched values, and if it finds one of those, it'll just dump all the parameters into that. So that means we can sort of make fairly generic substitute components that are reusable. There is one thing that can make things a bit more complex. If you have code like this, where you have a child component that you have an use the addref keyword with, where you reference the component, well, in that case, your substitute must actually inherit from the thing it's substituting. Otherwise, Blazor will not be able to assign that substitute component to the variable we have in this case here, the private bar variable. But it would kind of suck if you had to create substitute components for all the components you want to replace in your Blazor tests. So part of the preview package that is out right now for bUnit, we do have Stub. So anybody familiar with testing nomenclature might know that we have mocks, but Stubs is sort of a more lightweight mock. You can't really set up expectations, but it's just something where you can say, go and behave sort of like this. So we have built-in Stubs component, and the Stub component is a stub of the type of component you're substituting, and it is a Blazor component, obviously. So we get a thumbs up for the rule number 1 that it should be a Blazor component. It's also have that captures all parameters features with a little bit of extra sprinkle on top, so it makes it easier for you to get at those parameters you captured, so you can assert against those. So rule number 2 also checks out. Rule number 3, however, we can't really do that because stub of t isn't T. So we don't get to use addref on the child components and stop them out with this approach here. But it makes things a whole lot easier in many cases. So again, if you look at the bar and foo test, well, now we can just do component factories.add stop of bar, and then it will stop out bar. And this is our test, and it looks almost the same as before. Now we just find a stop of bar in our component tree when we go and search. You can also do this. Sometimes maybe you want to have a stop that actually produces some output, some markup in the DOM tree. And the approach to doing this is basically to pass in a render template like we see here, and give it some markup, and then you will find that markup in the render tree. You can see the markup matches here. It's probably not the best example I could have come up with, because this sort of assumes that foo doesn't render any markup, but if you bear with me, you can sort of see what's going on here. Another thing we can do is, well, maybe I want to stop out everything from a namespace, or if I have that third-party component. And what you can simply do is you can pass in that, a type predicate, I guess it's a predicate that takes a type as input and returns a boolean, right? So whenever you return true from this predicate, the component type is going to be stopped out. So this could be something like this, where anything that is a namespace that starts with third-party component is going to be replaced and just moved out of the way. And you can even take it one step further. I don't know how many of you have heard of shallow render before. Shallow render is sort of a concept that exists in other front-end frameworks like React and similar, where you basically say shallow render this component, and that will basically effectively only render the component and ignore all the child components. But we can emulate that quite easily. We can just say add stop and stop out everything that isn't the type I'm rendering, my component on the test, in this case foo. And then you only get to render foo, no matter how many child components you have now or in the future. So it's sort of a lightweight way of doing shallow rendering. Another thing that we might want to do to sort of get that third rule is to do mocking. And it turns out that you can actually mock a component most likely using your favorite mocking library. So if you're using, I've tested with MOQ and Substitution. I'm quite sure that TerraX JustMock will work quite well with this as well. It might actually even work better than the two, because it also has, at least in the paid version, ability to do things with shield types and with non-virtual things. But you can actually just mock a concrete type in using mocking tools. So you can say mock of foo or mock of bar, and that will mock the component. And why does that work? Well, mocks inherit from the thing they mock. So that is the first thumb up we have for rule number 3. Lifecycle methods on a standard Blazor component, a component that inherits from the component base type, which is the default you get in Blazor, well, all of those are virtual. And virtual methods, when mocked, they just get, they just do nothing unless you go and configure them through the usual mocking setup logic. So basically, the component gets neutered. It doesn't do anything now, because all the lifecycle methods basically don't do anything. So it's like having an empty component that only inherits from component base. The only exception is that if the component you are mocking has a constructor, that isn't virtual, it isn't substitute, it can't be sort of neutered, so the constructor will still run. That also means if you have any field initializers or if you have any property initializers, those will also run, unless the properties are virtual. And if you have any dispose async, they will also run again unless they are virtual. So that's something to be aware of. So this is sort of this might not work in all cases, but it will definitely work in most cases, I think. And there's one little trick we have to remember, and that is that mocking, sometimes you can't use the same mock instance for multiple. So if you have multiple bars in the same foo, you have to actually pass in 2 different mock instances. You can't reuse. Blazor doesn't allow us to have 2 instances of the same component different places in the component tree. So that's basically what that rule is. So let's look at an example. So mocking a single component instance, how does that look? So again, we have the foo and the bar example, and now I'm using mock, but like I said, most mocking frameworks will probably work quite well with this. So we're just creating a mock of bar, and we're using the add method to pass in the mock object, and say when you see 1 bar in the component tree, use this mock object instead. And then again, we render our component, and now we can actually go and find bar in our component tree. And why can we do that? Because the mock is actually a bar. So And that's actually what we want, because if we have that reference, we want a proper bar in our component tree. So that's also why we can go ahead and find that component and the component tree of type bar. And now we can actually go and look at the bar, the real instance of the bar rendered component, and we can actually verify that it is indeed the same instance as our mock component. So this just shows that it actually does the right thing. It actually replaces the original bar with the mock bar. So the next example would obviously be, well, if we have two bars in a foo, kind of sounds like a joke, right? It's the beginning of a joke. Two bars walks into a foo. Now, we can use, at least in MOQ type, I'm not expert in the mocking framework, but I found something called mock repository, and that's sort of a way for you to configure this, sort of have the same mock configuration for a whole bunch of mocks you create through the repository. So we create one of those, and here we, instead of passing the instance, we pass in a component factory function, basically an action that when it's called, it should return a mock instance of bar. And that's what we do here with mock repository. And now in our verification, well, we go and use find components, plural, to find all the bars. And now we can just use the mock.get to verify that the found instances of the bars are actually mocked components. The mock.get method would throw an exception if it failed, if it wasn't actually a mocked instance. So there's definitely some potential here. These bits here, the add method that allows you to pass in instances of bars, of mocked instances, or just instances you create yourself, if you like. This is still sort of preview bits for bUnit. So if you want to play with that, there's you have to get the preview versions in your NuGet package explorer to get that. I would love if you could come and join the discussion on the GitHub issues list for bUnit. If you have any feedback, suggestions for how we can improve this. This is potentially very good from creating, stable tests for your components, but and I'm trying to sort of make it generic so you can use your existing mocking libraries and don't have to basically build a mocking library in bUnit. That would be a huge undertaking. So if you have any input, or you maybe are an experienced user of MOQ or InSubstitute or JustMock or something, and you have some tips and tricks you want to share, please come and hang out and share with us. So, what did we see today? Well, we started by looking at why and what bUnit is. You also saw the hello world of bUnit with the counter test, and then we, whoops, I was a bit too fast there. And then we looked at what we can test, like should we use markup testing or verify markup, or should we verify component logic, and when should we switch between the two? We also discussed techniques for creating maintainable components, and again techniques for creating maintainable tests. And this is my next slide. So thank you very much for coming and hanging out in this, these special circumstances. Before we get to questions, I want to give a quick shout out. This is sort of a pet peeve of mine, but bUnit has had Progress Telerik and Swing Fusion sponsoring it for quite a while, and it's just great to have companies coming into open source and giving back and supporting open source. So if you out there have any influence on your company, go have a look at what open source you're using and maybe see if there's any way you can support that open source. It makes a huge difference as an open source maintainer to get support from companies, from the community. I would rather have it from companies because they, in all fairness, most likely have more deeper pockets than the rest of us, but it's a huge help to the open source community and helps keep motivation going. So if you have any influence over your boss or you are the boss, consider figuring out a way you can support open source. There's many great open source libraries out there that don't really have any support, so please help out if you can for open source sake. But yeah, thank you very much, and if you have any questions, now's the time. Otherwise, here's my contact info, and you can go and find me online if you want to ask questions later. Thank you. I can also say that I'm probably going to hang out in the Slack channel afterwards for this room. So if anybody is watching online, you can just ask your questions in the Slack channel. That's also okay. Otherwise, I wish you a very great rest of the conference.